So we're going to look at discrete random variables. I remember when I first learned this, it was very confusing. I didn't really know what the terms meant. So I think a good place to start would be to break down what these words actually mean. Discrete means it takes on countable values. So not necessarily whole numbers, but we can definitely count them in discrete chunks. Random variable is a function that assigns a number to each outcome in a sample space. And this idea is a little bit confusing, but it'll make more sense when we do an example. But yeah, it is a variable. So one thing we could say is that the values of it can change, just like you'd be used to in algebra. So let's look at some examples of things that might be considered discrete data to begin with, or things that are discrete would be something like the number of children in a family, the number of red balls in a bag, or shoe size. And this often comes up when I'm teaching discrete random variables, although this idea of discreteness. Shoe size, you can have a shoe size of like 10 and a half, right? But that's still discrete. It's not continuous data because it can't take on values in between 10.5 and say 11. So it's still considered discrete data because your shoe size isn't something that's measured. It's something that's going to take discrete chunks is sort of how I think about it. So let's look at a problem to sort of make some sense of this. So Mr. McDesmos created a discrete random variable for his golf results and displayed them in the table below. All right, we need to take a bit of an aside here, talk about golf for a little bit. One of my favorite things. Hopefully in golf, you know that a par is what you should hit on each hole. So if it's a par three, you get you get it in the hole in 3 shots. So that means you're not up or down. So a par would be 0. If you get it in, if you're playing extremely well, or you play the hole well, you get an eagle, means you get the ball in the hole 2 shots ahead of what you should get. Par is what you should get. Birdie is -1, par is 0, bogey is +1, double bogey is +2, triple bogey, and so on. So there's a bit of background information there about golf, but I think this is a good example to sort of bring this stuff back to the real world. So let's look at what this table might look like. So when we talk about the result, a -2 corresponds to getting an eagle in golf, a -1 corresponds to getting a birdie. And then obviously this data is made up, but let's imagine for a moment that this is the data here. And let's just explain this part because this is the part I used to not get. So the probability that our random variable, all right, so this capital X is what we're going to call a random variable. That's the thing that changes, right? That capital X can take on multiple different values. It can be -2, -1, 0, 1, 2, or greater than 3. You'll notice all of these are discrete. When you play golf, you cannot get a score that's in between values, right? It's not continuous. It's definitely discrete. So you're getting a score of 0, 1, 2, 3, and so on. So these are our lowercase x values at the top. So we're asking this thing down here is saying what's the probability that your discrete random variable takes on the values that are listed here at the top. So just to interpret this, there's a 0.001 chance that I get an eagle on a hole, right? A 0.079 chance of getting a -1, a 55% chance of getting a par, a 30% chance of getting a bogey, a 5% chance of getting a double bogey, and a 2% chance of getting a triple bogey or more, right? So on a random hole, see if we can answer this. What is the probability that he gets a par or better? So the par or better would be getting a 0, -1, or -2, right? So we are going to get, we would say, what's the probability that x is less than or equal to 0? Well, that's just going to be the probability it equals -2 plus the probability it equals -1 plus the probability it equals 0. Add them all together and you get 0.63. So I've flattered myself. There is a 63% chance that Mr. McDesmos gets a par or better. So I wonder how realistic this is. I might be This might be a bit better than I actually am. So there you go. Good stuff. Hopefully that made a bit of sense. Here's a problem, a bit more of an interesting one. Consider an area of your life that could be represented with a discrete random variable and create a realistic probability distribution. Feel free to let me know. I'm always keen to hear what things my students are interested in, and if they can link it back to maths, all the better. So I thought my example there just reminded me because my example is kind of golf. So good luck. Feel free to email me or let me know in the comments what you can come up with for your own discrete random variables in your life. All right, good luck.